Hello guys, good morning to all. So let me start with first of all, NumPy is built on top of the C libraries, so that's why it's very memory efficient and very fast. Then we have a lot of mathematical functions, and mostly in the mathematics we have the linear algebra, and then we have it's a container between. So most of the algorithms that we are going to see right in the sklearn and all, so they all in the core use the NumPy. So it's a very core thing that we have to. This is an important tool to deal with the data. Then what we saw is there are few important concepts. There are some important attributes when we create a NumPy array. Each array will have some characteristics associated with it, and those characteristics we can extract through this ndim. So ndim basically says what is the number of the dimensions that we have. Shape says what is the shape of it, like each dimension, what is the number of elements. Size is nothing but all the multiplication of all the numbers in this shape. And then d type is nothing but the data type that it has stored currently. So these are the basic parameters that we have with the numpy object. Okay, let us move on. So we use for importing numpy as np. Np is the alias that we give, but import numpy is the library that we use. Okay, so let us move. So what we saw is basically to create the NumPy array, first of all, we have to create a list, and that list can be used as an argument to the NPy array, NP array, that our ND array object will be created. Okay, there are some multiple ways to create this ND array, but one thing just we have to remember is we have to give it a list. We can't be giving it a numbers separated by columns like this. It won't work out. We also saw that there is a type precedence with the numpy arrays. So what will happen when you give it a multiple the data that you give, if it is having a multiple data types, there will be a precedence allocated to the array. All the elements within the array will get converted to a single type. So there is this precedence. Okay, so it starts with the bool. If it's a mixture of bool and int, everything will be converted to int. If it's a mixture of bool and int and float, and everything will be converted to float, that way it will give the precedence. As we saw in this case, when we have a third element as the, let me just make it once, import the numpy array. Yeah, so that's what we saw when we do this. When the list contains the float and then integers, everything will be converted to float. We can convert the types to different types using a d type argument to the np array. Then we saw some example like how we can handle a complex data types within a string. So this is the type of different data types that we have that we can use as a d type. In our case, we saw how the multi-dimensional objects can be represented. We saw that we took an example of like employees is a single one dimensional data. When we have a single employees data, it's a single dimensional array. When we have a multiple employees data, it will be a 2D array. And when we have a departments and each department is having a multiple employees, then that will be a 3-dimensional data. Okay, so the dimension keeps on increasing. We can have a company. Within company, we could have multiple companies. Within that each company there will be multiple departments. Within that, multiple employees, so that will become a 4th dimension. So this way it could keep on increasing, and there is no limit to the number of dimension. It just depends on the application. But as a humans, we could understand it till the 3rd dimension, but imagining beyond the 3rd dimension is a bit difficult thing. This one we saw, right? We saw that how the shape, dimensions, data type and size, we will define a 4-dimensional structure. Let us do that. Okay, I'll create one structure where we'll have a 4 dimensions. So let us do in this. Okay, so just define it. See, what I'm just going to do is I'm just copy pasting this whole second dimension to this thing here, and now I'll do yes. So that's how we can visualize it, Patrick. So as Patrick says, right, we can have the companies, and above that we can have the countries to add the 5th dimension. So that's how we can just understand it conceptually. Okay, so L underscore R dot shape. Shape is just says 5. Yeah, it becomes a bit complicated when we go beyond 3 to 4 dimensions. So let me just create a new example in this case. So we have this as a single dimension, okay, and this will become a two-dimensional thing now. After this two, yeah, this is now 3 dimensions. When I say, so now it's a 4 dimension. Within this, right, if you see, these are the single employees here, okay, and within that we have a department here. Again, similarly, we have single employees here, and within that we have a department. And to complete this whole department, we have this company here, okay, and again we have a second company here who's having a single department, and this department has 2 employees, and there is the second department who has a 2 employees. Are
Okay.
you getting the idea of it? Like, this is how the computer understands. For computer, there is no understanding. For computer, it doesn't need to understand. It's just a nested structure that we create, and computer just stores it. We have to understand it on top of it. So computer doesn't mean like this is the employee, this is the computer, but we have to interpret those things and we have to store it uh, that way. That is what is important. So we saw that there are few uh, cool functions available with NumPy, which are like numpy.zeroes, numpy.ones, numpy.empty, and numpy.eye. So these are basically, it will create as a array which will have just zeros, but that will be defined by the shape. So we will give it a shape, and based on that shape, it will create an array which will just have zero values. Then there is this ones which is just similar. It will create one values. Empty is basically, it's an empty. There is no defined one or zero. It doesn't define any one or zero. It could have sometimes a random numbers. Okay, but this is just to define an empty list. It will also be defined by shape, and there is this I. I is nothing but an identity matrix, and it will always have a shape where the number of rows and number of columns will be equal. Okay, that's called a square matrix, where the number of rows and the number of columns will be equal. Okay, as just an one example, I'll say that this, we see the zero, we have given it a shape of 3 comma 4, then it will create an array which is having a 3 rows and 4 columns with the values as 0. Then we saw there is this arange function and linspace function. Arange is very similar to what we have in list, which is range. So basic input is the start value, the end value, number of steps. Okay, so arange is very similar. Okay, just it will be a start value and the end value, but it will always be end minus 1. The end value won't be created. So for in this example, we have 10. So it's like 0 to 10. It will start with 0, it will complete at 9, but it won't go till the 10. This is about the range. And then we had a linspace. Linspace is very interesting, where what we just have to do is we have to give it a start value and end value, and we have to say like how many elements we want to create within this range. It's not like we have a step size of this or something. Computer will automatically divide and decide, but what we just tell is this is the start value, this is the end value. For me, create a equal distance values. Those will be 10 values. That is the benefit of linspace. We saw an example of sine here, where we had a 2 pi, and till the 2 pi we created equidistance values. We assigned it to sine. Sine gave a value, and that we plotted it. Then we have this lower triangle and the upper triangle. Try L and try U. We just prints out the lower triangle and the upper triangle in the matrices point of view. So what we then saw is how do we print the array. So printing is basically like we directly print it. There is no difference in that. Okay, just an example here was we use the reshape. The reshape lets us the shape, as I told, right, it's a very important feature that we have, which allows us a lot of flexibility. And in this case, what we did is we created a range of 16, which is just a single dimensional array of 16 values, but we used a reshape. So reshape just gave us a three-dimensional array here. Okay, 2, 2, 4, where the third dimension will be 2, second dimension will also have 2 elements, and the third dimension will have 4 elements. Okay, it converted the 16 numbers to this, but this dimension's size should always be equal to this. Okay, so in this case, 2 multiplied by 2 multiplied by 4 is nothing but 16, and we have a 16 values. If these doesn't match, it will throw us an error. So that we have to be careful. We saw those examples. This is just similar. Okay, just we saw that we can just limit the number of printing that we have. Okay, if sometimes there is a big value, it will just take up all your notebook space. So there is this threshold, print option threshold, which will just limit what is going to be printed, how much elements to be printed on the screen, and others all will be hidden. And then we saw basically few functions that are available in NumPy to generate different random numbers with different distributions. Okay, we saw like uniform distribution, where all the values will have a uniform probability. Every value will have a equal probability of being selected. Okay, and we saw this rand n, which basically creates a normal distribution random values, which will be basically this value generated to have a mean of mean of 0 and standard deviation of 1. We plotted those values and we saw that this is a uniform distribution where we see that each value is having a almost equal probability of getting selected. And in this case, it's a normal distribution where it follows a pattern of this normal distribution and computes the random digits. Okay. We even saw that if we want to generate a values between a numbers, then there is this rand int. So what this does is you provided either two arguments, which is just a numbers between which you want the random number to be. In this case, it's 1 to 7. So we want numbers to be between 1 to 6. 7 will be excluded. And we say that we want to generate a 20 numbers. This is just an example of to say that we want to generate a 20 samples of a dice. Okay, so dice is having a 6 values. So we say how can we generate a simulated version of the dices. So let us move on to the more, and we can also give the shape here. Okay, with the shape also it will create a value similar to this. So there are two ways: you give it a shape or you create it in this way and do the reshape. Okay, then we saw basically the arithmetic operations. With arithmetic, all operations are there: plus, minus, division, multiplication. But the thing will be element-wise arithmetic operations. Okay, that we have to remember. So element-wise basically means from the two matrices, each one corresponding to the similar location, the same element. So in this case, 20 will be added with 1, 30 will be added with 2, 40 will be added with 3. So what is happening is each element from the two arrays within the same positions are getting added. So the shape should be same. That is one condition that we have to maintain. If the shape is not same, it won't work out. So basically we saw that these are the operations, and after that, so there are a few more operations such as this exponents. Okay, but there are also scalar operations. So there are two options. One, we need to have a shape, its shape should be similar, and the two, we can do it with the scalar operations. Scalar basically means we just have a single value. We want to do that single value. We want to use that single value to change all the elements within the array. So such as we can add 2 to each element, we can subtract 2 from each element. Those are the things that we can do with the scalar values. And there are this Boolean operations. So with Boolean, what we are doing is we say a is less than 35. What it will give is for each element, it will check for this Boolean operations whether that number is less than 35. So wherever that number is less than 35, it will return true, and for all others, it will return false. Let me move on with the matrix operations. With matrix, what we saw is again it is just similar, but we just have to maintain that the shape should be similar. Otherwise, it will give us a problem. We just saw that there is just a confusion within the people that there is this matrix multiplication, that is linear algebraic dot product, which is basically what we saw, like how it works. So for that, we have to use this a dot b, and for the element wise multiplication, which is similar to cross product, we have to use the multiplication. Okay, those are the two differences. So this is the dot product, and that is the normal multiplication element wise. So there's this two way how we can represent this dot product. That is the array dot the second array, or we could use a different notation which says np dot dot first array and the second array. Okay, those are the two different notations that we have. We also saw that for the dot, there are some conditions such as the last dimension and the first dimension from the second array should match. Okay, if not, it will give us an error. So that's all we saw regarding this. Then we saw that there are a lot of universal functions available within NumPy, such as sum, minimum, maximum, mean, standard deviation, cumulative sum, and the correlations. All kind of things are available. Okay, so those we can use. So the list of them are all here. Just a thing that I wanted to again show here is the access part. The access is basically very important. When we're doing the operations, we have to understand like what is the access we want to operate on. Okay, when we have this A and when I say 0, it will go in this flow. Okay, it will go in this up to down flow and take the operations on each element. And when I say axis equal to 1, it will go in this direction from left to right, okay, and do the operations. So when I do this axis A as A dot sum, what it's doing is going like this and taking sum of all the elements. So 0, 4, 8, 1, 5, 9, 2, 6, 10, 3, 7, 11. So it's like going so each column, it's taking a sum of each column, okay, but going in this direction, axis 0, and then the axis 1 goes in this direction, okay, and takes out like this element's addition, this element's addition, and this element's addition. Okay, that's how the 0 and 1 was. Yeah, then we saw like how we do the indexing slicing operations. So indexing basically, we have like what happens is we have the square bracket similar to what we have in the list. For the single dimension, it's just the way we access the list. But with multi-dimensional, what happens is based on the dimensions available, we can have that many comma separated list like indexes. If we have 3 dimensions, we can have 3. So for each axis, for each dimension, we can specify like what is the elements that we want from that dimension. Let me just give you this example here. In this case, what we're trying to do is A 2 to 4. Basically 2 in this case is 0, 1, 2. It will start from here. 3 and 4. 4 is getting skipped. So it will just 2 and 3. And in the column wise, it is going for 1 and 3. So it will be 1 and 2. So 9, 10, 13 and 14 is what we are trying to select in this case. So there are just few more ways, like if we want to select all the rows or all the elements within that axis. Okay, within that axis we want to select all the elements, then we have this colon feature. So with this colon, it will select everything within that axis dimension, and in the other dimensions we can specify. We do have a similar kind of way in list again, such as the minus, which will start from the back of the list. Okay, from the opposite side of the list, it will start the indexes from there. Similar to colon, we have this 3 dots also. Okay, it just means similar thing. Just the difference between this and this is just limited to the dimension we have. Okay, we just take the first dimension, we want to select 3, second dimension we want to select everything, but we are not specifying like what are for the other dimensions. This 3 dots, right, what that does is they say for all the dimensions that are coming ahead, just select everything. Okay, if it's a 5-dimensional array and we want to select like everything from there, but the first dimension only select 3. That's what this thing means here. So there is this 3-dimensional array structuring. Please check this. It has matrices, concepts explained in simple manner. Everyone can have a look at it if you want to go into the matrices. If you want to understand, like revisit the matrices again. Let me move on. So we just saw like how we iterate through the elements. Okay, for each elements, for each axis, right, we can start accessing for each for. For each for, it will start accessing one by one dimensions. So for the first for, it will be starting with the first dimension, okay, which is such as in our example, just to give the example, it's like a departments. It will start with the first with the departments, then within the for again, we will have each employee from that departments. So we saw the example here also. Okay, we had this 3 and 5-dimensional array, and when we gone through this for loop, okay, we started, when we go to the top right, the first array basically says the department level, and within that we will start having the employees. Within that 5 values will be there. So that is how we can iterate through the list. We saw there is this flat which basically returns an iterator to access each element in a flat manner. Flat basically means there won't be any shape. It will be just a single dimensional array. All the shape will be removed and it will just return out a single dimensional array. And then we saw this ravel thing. Ravel basically returns as a list, not list, but this is a numpy array, but it returns an actually shaped removed array, whereas the flat basically returns an iterator, which is helpful when you have to deal with a bigger array. Okay, which will have like a millions of rows. Then it's better to have the flat object. When we have a small list, then we can use the ravel because it will just return a array within array to us direct. Then we saw this t is to do the transpose of the object. Basically your rows and columns will be interchanged, so that is the use of t. Not the coin flip. I have given a data file which basically I extracted from a Kaggle.com. So Kaggle.com is basically a site where there will be a lot of competitions related to data science and all. You all can give it a look. It's called the Kaggle.com. That the coin CSV file is. So Kaggle.com basically hosts a lot of data files which you can use to create some models and try on with your own things. So I extracted basically a coins data, which was a very bigger file, but I just made it a smaller file, and we are going to use that file in our example here. So let me first load that file. Let us have a look at the file again. Okay, this is the file structure. So what we have in this file is we have the currency data. There are like different currencies: Arch coin, ADX net coin, EF coin, OX coin, and there are 28 days. And for each day we have open, high, low, close data. And I have a date which is just at 1 to 28. What we are going to do is we are just going to select this 5 columns from the data: open, high, low, close, and dates. These are the 5 columns which are going to extract. Those are the features basically that we have. So let me just give you one more thing. So what we can do in this is we can do this also. Okay, this is also the feature that we have with the notebook, which we don't have with the normal in the lab, which we don't have in the. So we can have multiple files. So I can again open one more file and which can just open here in a half split. Okay, those are some cool features that we have with the lab. So let me close this file here and I will load the data. So this basically functions. What it does is this is the np generate from text method. It takes the name of the file and it asks for the delimiter. Delimiter is basically comma, as we are having a comma separated file which is CSV, and we say use columns. So columns are basically from 2 to 7. As I said, we are skipping the 2 columns and we have the remaining 5 columns. Then we have a skip header equal to true. As the header contains the header related data, we just don't want that. So it will just skip it and start with the data. So let me run this thing and let us print the data. So what we see basically is the whole data is here, but you just have to see that this 28, right? This is related to first coin. This 28 again is related to the second coin. This 28 is related to third coin. And this 28 is again related to the fourth coin. That is how the data we have. Let's move on. So this is just now, right now, let me just print the details for each like shape coins data dot shape. Then we have the shape and dims. Okay, so the basically shape here is we have 112 rows and 5 columns, and the dimension is right now it's just 2 dimension. And as I told you, right, within the file we have this coins related data is tagged at row level. Okay, so this data here is basically what we want to extract. Okay, so how do we do that? Coins data 1 to 2, but how do you say 1 to 2? Because if you see, right, the dimensions is 112 comma 5. If you see this 112 is nothing but 28 multiplied by 4. Let me tell you, this second coin is stacked over the rows. We have to extract this rows. Columns, we want all the columns. Okay, we just want to extract this rows. So how do you come to that, guys? So just 2 comma 2 will be a column you are selecting, not 28 28 and 2. So as Patrick gave, right, so it will start with the 29 and 57. But just to be clear here, we won't start with the 29 because our indexes start from the 0. So we have to go from 28 to 556. You all getting me right? Yes. So that's how we have to select in this case. So it will start with 28 and it will go till the 26. 1 to 28 rows. Now let's move on. So the second question says we want to select the, so that say all columns within those rows because columns is empty. Yes, columns is empty. If we say the colon thing, right? So everything will be selected. So let us now do this thing. Select third cryptocurrency and top 10 rows and open close prices only. Let me open the file. Now rather than file, I'll just show you this thing above here. So what we say is we want to select the third cryptocurrency data now. You all must be good with that now. And we just want to select open and close. Okay, we just want to select the columns open and close. You getting me? This is first column. This is 0, 1, 2, 3. We want to select 0 and 3 columns. So we want to select the third cryptocurrency and the top 10 rows. So we want the third cryptocurrency. So first of all, so guys, so we have the 10 rows now. I had a mistake there. Now to just select 0 and third column. Yes, how do we do that? So do we do 0 to 3? Only 3, but we just want 0 and 3. So how do we do that? Yeah. So I have not told that. So let me tell you. Okay. You got it. So what we are doing is basically a list. So what we give inside this is inside this range is nothing but a list. What this 56 to 66 returns is nothing but a list. So again we are also giving a 0, 3 as a list. Okay, so we got the 0 and the third columns in this case. Now what I want to do is, so I want to create a 3-dimensional matrix now. I want to reshape it into 3-dimensional matrix where I says my first dimension is going to be the 4 cryptocurrencies, second dimension is going to be the 28 days, and the third dimension is going to be the 5 features in a day. So this reshape thing, right? Yeah, Patrick, I was mentioning to you yesterday, how do we use this reshape and why do we do this reshape? So in this case, we had a whole rows, right? Single 115, I guess 115. Yeah, 112 amount of rows in a single list, but we want to split it now. We want to split it into dimensions and we say points data dot reshape. So basically we are trying to reshape it. This 112,5 data, we want to reshape it to this 3 dimension. Okay, we have first dimension that will have a 4 bigger chunks, and within each chunk there will be 28 rows, 5 points reshape equal to this. See, right, what has happened is, so now each cryptocurrency 0 to 1 to 28, 1 to 28 has all got chunked into 1 dimensions now. This is how the reshape is useful for us. Okay, yeah, and then what it will do is it will start with the bigger data, the whole 115 data. It will first split it into 4 structures. On the basis of it? On the basis of this whole structure here. Okay, this whole rows, right? This all the rows will get split into 4 divisions. It will divide 112 by 4 and will create those chunks first of all. Okay, it will divide them into equal 4. Okay. Then after that it will go into 28. So everyone will have 28. And then within 28 it will create 5. So first thing what will happen, right? It will just flat it. It will just flat it completely. Okay. For example, take 115 multiplied by 5. So it will have a flat data. 115 data points in there, right? 112 multiplied by 5. That's those whole flattened data will be there, and with that flattened data what it will do is it will first take out the 4 divisions. After that 4 divisions it will try to make a 28 divisions, and within the 28 divisions again it will make a 5 divisions. No, divisions, there are many combination permutations are there to divide. Of course we can take it, right? I can say how here exactly how exactly it is giving how we want output. So in this case the problem statement is important. What happened is what we defined, we want our 4 cryptocurrencies to be separate, say 28 days. We know the structure of the data, right? As we know the structure of the data, based on that we are trying to create these divisions. We are not creating these divisions randomly. You got it, right? Those are not random. We know we have a 4 cryptocurrencies data, and we have 28 days, and we have 5 features.
Let us
Based on
try
that,
like this, no? Then let us try like this, no? Only reshape, only 4, not
yeah,
28
only
and 4.
4. Okay. So let us make that thing also. I'll keep it separate. So let me say -1. So -1 basically means anything beyond that 4 divisions. So just create me a 4 divisions. You decide all other things. That's how that means. And in this case, right, the structure is just 4 dot shape says 4 comma 140, right? But for you it will be very difficult. So we will see like why we did this division. We will come to that also, how this splitting of the reshaping of the data will really help us.
It looks like data manipulation is quite easy with Python.
Yes. So now what we can do is we can take out each data, like what we had to do
Because
earlier. What we had to do was we had
if I want to cross-tabulate the data from data frame, I need to
yeah,
give more number of commands in R. But here it
right.
looks like very simple.
Yeah, it's simple. So see what we basically did in the start. So what I told you all to do was in the start we had to decide these numbers like 56 to 66. We had to calculate these numbers. Now that has been removed. Okay, now what we do is see the beauty of it. Now what we can just do is coins reshape. We just say 0. We got the first coin. Getting me? We
Yes.
got the first coin. And after that, if I say 1, we got the second coin. And now if I want to select the third coin and the top 10 rows, right? And now if I just want to select the first and the third row, we got it, right? It is just it's not in a structure, but if you see, this is the top 10 rows and these are the top 10 rows for open and close. We will go step by step. So the next question basically says, let's add first coin and third coin into a new array, but we want to keep the last column same. How do we do that? Keep this last column. Don't want to change this thing, but we want the addition of first and third columns, these 4 rows. How do we do that? Let's do this and move to the new class. Right, so let me first take the coin first. So I have this coin first, coin third, coin first and coin third. What I do is I want to create an addition of these things, but I just want to add the 0 to third columns, but I want to keep the 4 column as it is. How do I do that? We create a shape of zeros. What it will help us is, so what it is going to help us, it will create as a blank data for us. Okay, it will create a template or the skeleton for the new coin, where it will have the 4th column also. Now this new coin 0 to 4, then we have coin 0 to 4.
Plus,
Let me just remove this thing. It will be just 0 to 4. We have coin 0 to 4. So now if you see this, right, new coin, what we are seeing is the addition got it here, but this thing is still blank. So we can manipulate this thing now. So what we will do is 4 equal to coin first, the coin zeros, the ones. So when we use the ones is when we do the multiplication. Ones are really helpful when we have the multiplication. 0 we use when we want to do the addition kind of things. With the ones, right, multiplication becomes easy. No values will go. So we use the numpy.ones to create a blank structure when we want to do the multiplication. The numpy.zeroes, we create a structure when we want to do the addition and subtraction. So in this case, we created a blank matrix with the 4 columns, kept out the, and we just changed the 5th column to the new value. So we got, so what we are going to say is few basic things. We have gone through the basic thing, but there are few more advanced things like how we are going to deal with these data sets. So first is, let's start like, if we have a different array elements and we want to stack them, we want to merge them basically together. So how do we do that? So we have, let's create a random numbers of 2 by 2 arrays. Okay, we got a 2 by 2 arrays A and B. So there is this V stack. So what this V stack basically means is vertical stacking. Okay, this means vertical stacking. We can use this np.vstack. We give it A and B. If you see, right, 59369201. So this is how it has stacked the data. But you have to be sure that this dimensions, the column dimensions should match in this case. If not, it will give you the error. So we can have like 2 to 4. This won't work. We need to have 2 to 4. It will work out. But if I make it 3, it says gives us error. Okay, so that we have to validate that the column vectors should have a similar shape, but the row vectors could have a different shape. That is okay. So there is similarly the H stack. So what H stack will do is why we are using 10 star. Okay. So that is basically the random numbers, right? Those are generated. These random numbers are basically generated between 0 to 1. Okay, we can have the rand int, but in this case they are generated between 0 to 1, and we use the multiply by 10 to give them an integer value. Yes, so we can have the rand int also. What happens if the data types of the two arrays being stacked don't match? The precedence rule takes over. Data types is not a matter. Data types won't affect in this case. Yeah, but the precedence will take over and it can merge the things. In this case, we did the V stack. In this case, we did the H stack. Okay, so H stack will also similarly work. But in this case, we have to validate that the rows will be of the same shape. Okay, so we saw H stack and V stack. Now let's move on to, there is this concatenate. Okay, this is more advanced thing. So what concatenate is doing is it will basically try to concatenate it based on the axis. What it does is it based on the axis. So we know, right? So 0 axis means it will do the row wise. Okay, when we do it by 1, let me run it here. And in this class, we have more examples for the axis for the same coin data. So we could have the 0, which is a row structure, and the 1 where is the column structure. So there is this column stack. So what this column stack and row stack? I guess there is also one row stack. Yes, so there is also row stack and there is a column stack. So this is basically for the one-dimensional vectors. So when we have the one-dimensional vector, we just want to do the column stack. We want to stack them column wise, and we want to stack them row wise. So this is all just a similar methods. The numbers are very similar. Yes, 4 to 2, 8. Let me just change the numbers a bit. 4, 3, 6. So it's 4, 3 and 6, 8, and it's 4, 3 and 6, 8. Okay, so these are basically the H stack, V stack. We saw the concatenate, and V stack column. We saw column stack and the row stack. Okay, these are basically used to combine multiple arrays into single one who have a similar features. So let's move on to broadcasting thing. So broadcasting is one important thing. So let us see like what is the features that we have. Okay, so when we're dealing with element wise data, so what I told you is we are just going to deal with the two types. One is where the shape is completely similar, and the scalar part, but it's a bit more complicated than that. In the simplest case, the two arrays must have exactly the same shape, as we already saw that. But what broadcasting does is it relaxes this constraint when even this shape constraint doesn't meet. Okay, we will see how it works. So when operating on two arrays, NumPy compares their shape element wise, and it starts with the trailing dimension and works it forward. Two dimensions compatible when they are equal, or none of them is 1. So let us see the examples. Okay, so we have 4 by 4 matrix, and in this case, okay, so there are now 4 values. So I have created a one dimensional array which is just a 4 values 1 0 2 3. And if you see, right, what I did is start plus new array. So now you know start is having a 4 dimensions, and new array is having a just 4 dimension, 1 dimension. Did you see what happened? So what it is doing is it's working similar to the scalar feature, but just the difference is it's trying to replicate it to the shape of it. So what happening is the first shape is matching. Okay, 4 and 4 are matching. It is repeating it for the same shape again. It's doing 4 multiply by this 4, the other part, and repeating it all the time and adding it. So what we did is, what we earlier told is there are only two ways to add the elements. When we have the shape completely equal, and the other is we can use the scalar values. But Python broadcasting just relaxes this feature. What it automatically does is, if we have one array which has the first shape matching, in this case 4 and 4 is matching, and the other is not matching, NumPy will automatically replicate this to this many times. For the 4 times, and it will add it up. Okay, it is going to replicate this thing and adding it here. So now let me make a 3 comma. So what I'm gonna do is we will try to add this thing. But if you see now, operands could not be broadcasted together with shape. So in this case, we try to have a 3. Okay, so what happened with 3 is not matching with the shape. So it says we cannot replicate this thing. Even if we replicate, it still won't match with the 4. Okay, so this thing replicating doesn't matter. But this is not same, so it won't work out. Okay, let's see a few more examples. So this is basically the same. Now what we will do is we will try to transpose it. Okay, transposing basically creates a column wise vector. We had a row wise vector, but now let's create a column wise vector which will have 4 comma 1. But this column wise now what's it doing is it's now adding it in this way. Okay, it is basically trying to relax it. And what we can do with our coins example, for example, if we want to, for all the columns, if we want to make some changes, let me mute everyone. What we have is then we did the transpose. With the transpose, what it does is it's trying to add it on the column level, not on the row level. Basically, the broadcasting, this is just a unique feature when we just have a single element and we want that single element to operate on all the elements. So that's where the broadcasting really helps. So scalar will always help, that we already know scalar is going to work, and these things also works when we have the same shape, that will work. When we add the shape scalar value, that will work. Just this broadcasting helps where we don't have the other shapes. The shape, at least one dimension is similar but the other dimensions are not matching. So at that point this really helps. Okay, that's what about the broadcasting thing. So I just didn't tell about the vectors. What this vectors does is, yeah, so what vectors really does is it's nothing but a, so what we did in the second case is just we just converted this, we just transposed this matrix. So when we want to, so now it's operating on a row level. But when we want to make it operate on a column level, right? So we just can transpose this data, what we tried here. We did transpose this data here in this case, and we did add it. Okay, so in this case, what's happening is it's now working on a column level data. It's replicating this way. Okay, those are the two things. So vectors are nothing but, what we have is vectors are nothing but a single dimensional data. It's mostly in a transpose shape. Okay, it's a single dimensional data in a transpose shape. So in this case, this is the vector. What we did is we just said that everything has a column. There is this one thing, np.new axis. What it does is it will just create a blank axis where there is nothing. Okay, but this is just similar to b.transpose. Okay, so that's a vectors. Vectors are nothing but a single dimensional arrays. Let's move on. So we saw how we can merge the data, but there is also a way to split the data. So in this case, we have a H split and V split. Okay, so let us see. It's just similar to what we have in the H split and V split, but just the differences are we are trying to split this data into 3 parts. Okay, what's happening is it's creating a 3 arrays here. So this is the first part. So what's happening is we have 12 columns. So what it's doing is it's converting into 3 columns. It's converting into 4 columns. So there is this first 4 columns. 5 to 5115 is again the second column, and 1770 is again the third column. So this is basically horizontal splitting. It is splitting into equal parts. So let us also see what will happen when we don't have the equality. It will give us an error. We'll say that it can't do the equal division. Okay, so this is really important when we have the equal division. So let me keep this thing also. Keeping this thing will also help you. Yeah, so when the size is not equally dividable, it will give us an error. So horizontal splitting won't work. So there is this way where what we can do is we can specify the split labels. Okay, let me print out the A first. Yeah, so in this case, it's making a split at 3, 0, 3, 6. It's making the split at 8 after 3, 4, 5, 6, 7, 8, 1, 5. and again it's making a split at 9. So after that it will just create a one dimensional array, and after that whatever is remaining will come into the last one. Okay, this is the split that we are creating. So this will be also helpful if you think of a coin point of view, right? Within the coins, we could have make a split at 28, 28, 28. It would have given us a new rows each time, given us a new array for each coin. Similarly, there is this vertical split. It won't work now. Okay, so vertical split will work because out of 4, it has created an equal division. Similarly, we can also say 1, 3, the splits. Yeah, so this is how H split and V split really works. Now let's see about the copy part. So how does the copies really works? So as Patrick was mentioning, right? So what happens when I'm doing the equal operations, when I'm trying to assign the object to the new one. So when I'm doing creating an array here, a is equal to np.arange 12, and I say b is equal to a. So what I'm doing is I'm assigning a value of a to b. Okay. If I say B is A, so what this B is A basically means is, are these objects similar or not? So when I say B is A, it says yes. So they are both pointing to the same copy. Okay, they are both pointing to the same instance. Now let me say B dot shape 3 comma 4. So this is just similar to what we have a reshape. Okay, what we have as a reshape. So B dot shape 3 comma 4 will also work in a way reshape works. So for the A, if we see, it didn't had any shape till now. It is just a one-dimensional array. Now I'm trying to change the shape of B. Okay, now B's shape is changed. If I check the shape of A, it is also 3 comma 4. So you guys see, right, what's happening is when we do the B equal to A, we're assigning the value of A to B. It's keeping the same copy. It's not making the new copy. It's just pointing to the same instance. Just a variable name is different, but both are pointing to the same copy. Whatever changes you make in one will be affected in the second. Okay, that's how by default it works. Okay, and when we make the changes to A00 to 10, the changes will happen in B also. Okay, that's how this copy is. It's not creating a copy. It's just working on a same instance. So now there is also concept of view or shallow copy. Okay, what this does is it will create a new array name and we'll just keep a separate thing for metadata. What I mean by metadata really is, let us see it. So what I'm doing, C is equal to a dot view. Okay, we are creating a view here. What this view does is, so let's see. So what I'm doing is C is A. What I'm first checking if C is a or not. So in this case it says false. It says not C is not A. But C dot base is A, it says true. What it's doing is C is creating a copy, but it's not a completely new copy. It's just creating a new variable, new structure to it. It's still pointing to the same data, but just a different structure. We will see what I mean by that. So when I'm trying to shape or changing the shape of C dot shape 2 comma 6, but shape of A is still 3 comma 4. I've changed the shape of C, but the shape of A is still same. What's happening, I mean by metadata is both are storing the data in their own way. They are just storing the structure, not the actual data. Actual data resides, but the structure, they're keeping their both keeping them as a separate. So when I'm changing the shape, it is 2 comma 6, but for the A, it is still 3 comma 4. When I'm changing the value of C 11200, C has changed. Okay, let me make these few changes here and let us print A. Okay, so what has happened in this case, if you see, data has been changed. The 100 value which we changed in C got changed here. The value 10 which we had in this case got changed here. Okay, but the shape is still very different for the both, but the copy is still same. If you got the differences between the view, the shallow copy, and how does the real copy works, means when we do the assignment, we have to be very careful with the assignments. You do the assignment, you make the changes, your original copy will get changed. So those are the things that we have to be very careful, and this thing you have to remember. Otherwise, when you make an assignment and make the changes, all will blow out and your original value will get changed. Same cases with the view or shallow copy. And when we want to create a complete different memory representation, then we use the a dot copy. So this will create a completely new memory to it. The changes to the one will not get impacted to the other. So that is just a dot copy. Okay, making a changes to d doesn't change into a. So I'll just repeat it again, guys. So there is just this three ways. What's happening in the first is when we make assignments from one array to the other, we give it a new variable name. What will happen is it will be a same memory structure. Both are pointing to, both are similar object, just they have a different name, but are completely pointing to the same instance. Whatever changes you make, the shape, the variable values, everything will get changed into the original variable. Then we have the viv or shallow copy. We call it by a.view, the variable.view method. What it will do is it will create a new variable with its own structure. That variable can store the data in its own format, but the data it's pointing to is still the same. The elements which it's pointing to in the memory are still the same, but it can change the structure of the data, the representation structure, such as we can change the shape here. Okay, but the original shape in the A is still same, but for the C only the shape got changed. Whatever values we change in the C and A will get impacted into both, because the values they are pointing to are still same. This is just to see that both the values are completely same. Okay, and we just use the copy to create a new copy when we don't want anything to get impacted. Both will have their own separate memories. Just to be careful with when you are dealing with a large data files, because it will create a two memory points to the same data. Okay, so let's move on to the advanced indexing. So few things that we have to deal with advanced indexing is what's happening. We just what is the practical use of copy if only a deep copy is truly making a copy? Okay, with the advanced indexing, what we are going to do is, let me run this thing. So I created a A. In this case, we see we have generated some square root numbers here, square numbers here. Okay, for each index, and there is this interesting index structure. What we did is we created an array which is having the index numbers that we want to extract. Okay, this is a array which is just storing the indexes, not the actual values. This is storing the indexes that we can put here AI, and it will just extract those values. They can also be repeated. In this case, 1 is repeated 2 times. It gave the 1 2 times here. 3, the index is 9 as it is square. 8 it is 64. 5 it is 25. Okay, we can use the indexing in this way. There is just one more format where we can use the multi-dimensional indexing. Okay, what is happening is it will output the array into a similar dimensions as the indexes. So these are indexes that we have to remember. So this is the third, fourth, ninth, and seventh. Yeah, so if you see, for 3 it is 9, 4 it is 16, 9 it is 81, 7 it is 49. But just see that the earlier is it's a flat version, and when we use the multi-dimensional index format, it gave us a multi-dimensional output. So that's why it is called advanced indexing. You can use this advanced indexing structures to extract your data in a way you want. Okay, there is this one more example. In this case, what's happening is, so we have created a palette. So this is just a image representation format. Okay, this is like 3 triplets of colors, red, green, and blue. So we have an array of this. Okay, each one is containing 3 elements, and this is a 2-dimensional array. So what we are doing is, let me run this part. So see, when we are trying to access the 0, this is first of all a 2-dimensional matrix again as the output. In this case, it will extract the 0th row, this whole thing, the first index, this whole thing, the second index, this thing. If you see here, second index is this thing here, 0 to 55, this one, and the 0 again, this one. Similarly, in the second array, we have 0, 3, 4, 0, 0, 0, 3, 4, and 0. Okay, this is a bit complicated, but just see that you have to practice with this bit. I know, just try to understand. You can run these things on your own again to see like what is really happening. Okay, but we can try to make few more changes. Like I can again say I want 1 here, 2 here. It will just try to append that thing here. It will 1 will be appended, the first one, and in this case it is second one. So that's a multi-dimensional indexing. So that's not multi-dimensional indexing, that is just creating a multi-dimensional index output. So when we have a multi-dimensional data, this we were dealing with the one-dimensional data. Now when we have a multi-dimensional data, if you see, I have created a I structure here and I have created a J structure here. Both are nothing but 2 by 2 matrices. What's happening is A I am giving I comma J. So what this will do, in the first output it will try to capture 0 comma 2. 0 comma 2 is basically this element here. Okay, 0th row and second column. For the second element it is 1 comma 1. So 1 comma 1 is this thing 5. So from the column rows it is 1, from the columns it is 1, and it will access the 5 element. For the 1 comma 3, so 1 comma 3 will be 1 this row, 3 will be this row, it is 7 if you see here the output, and 2 comma 3, 2 comma 3 is 2 here and 3 here, so this is going to be 11. Okay, so this is right, this is a multi-dimensional indexing structure that we are using. So rather than giving it here like which are the sections that we want, we are creating a complicated structure of indexes that we can use to access our data. So what we did is we gave it directly I comma j. So in this case it's not like a single dimensional or the first we have to give the first dimension, we have to give the second dimension comma third dimension. In this case it is not the case. Yeah, it is the case. What's happening is this is the first dimension, this is the second dimension data. That's how we are dealing here, but we can't combine it. Okay, we can combine it and create a new array and give it, it won't work out. This has to be like the dimensions. The I is basically pointing to the first dimension indexes, the j is basically pointing to the second dimension. I can make it a bit easier if you want to understand. Like what will happen is I just want to capture like 0 0 comma 1. Let me take it 0 comma 2. Okay, the way we take it, not this thing, this is basically this thing. This is just similar to what we have here. Like we are trying to take 0 to 2 and then we can say again 1 to 3. So first we are trying to access from the axis 0 and then we are trying to access from the axis 1. Similarly, this will also work out like this indexes are from the axis 0 and these indexes are from the axis 1. So we can make the changes also in this case. Similarly, we can change the elements through this indexes. So if you see, we created a range first where we have the 0, 1, 2, 3, 4 and then we use this indexes 1, 3 and 4. Okay, so 1, 3 and 4 is basically 1, 3 and 4. We assigned a 0 value. We can change those using this indexes. I guess I've not shown you in Python, right? Have you seen this? Means I'm not sure I've told yet, but print, we can assign elements to the variables by comma separated. So such as what I'm doing in this case is a comma b comma c equal to 10 comma 12 comma 13. So this thing is respectively being assigned to each variable. So 10, 12, 23. So guys, similarly what we can do in this case is, so we took this index as 0, 0, 2 and what we are trying to do is give it a new array that will be assigned to 0th index, 0th index and second. So if you see, we have taken 0, 0, 2 times. So what will happen in this case is, it will first assign 1, then it will assign 2. Okay, so when we run it, the value that finally being assigned to 0 is, what has happened? Okay, I made the changes to a. That is the one problem which I have. So I'll remove this thing. Yes, so for the 0th one it got assigned 2 and for the second one it got assigned 3. Okay, so that's how we use some advanced indexing. These are rarely used, not much. You can look into it, but yeah, mostly you will need to Google it because you won't be practicing this thing regularly and you won't remember these things. But just give it a look. So whenever you see over the online people using it, you'll at least know like what's happening. So let me move on with the Boolean indexes. So earlier we saw that, right? In Python, when we use the logical operators with the NumPy arrays, what it does is it will return us the array with true and false combinations. So wherever it matches the condition, it will return true, and wherever it doesn't match the condition, it will return as false. Okay, so in this case, if you see, we compared a greater than 4, and what it has given is true and false. Okay, so when I say a of b, it will just return me elements where those values are present. Okay, wherever that is true, it will try to access those elements. So that's what I was telling you earlier, right? When we have this true false things, it's really helpful. Okay, even in this case, we can replace this with a is greater than 4. Okay, let me also try one thing. A is greater than 4 and a is greater than 6. It doesn't work. So guys, this is how this Boolean things really helps. So we can use them for indexing again. Okay, so we want to filter out things. So such as someone was asking, right, we have to take out uh, the values where some values are greater than some threshold. So we can use this to take out, I would say, a underscore 4 equal to a is greater than 4, and a is less than equal to 4. Okay, I would say a less than equal to 4. Yeah. So that thing, right? Earlier I told means what happened with np dot a range is this single dimensional data. So this is basically from 0 to 11. This is single dimension, but we want to give it a multi-dimensional shape. So we reshape it to 3, 4. So what will happen? Now it will create a two-dimensional data. Okay, it will just structure this data into two-dimensional. So 0, 1, 2, 3, it will split 4, 5, 6, 7, 8, 9, 10, 11. Yes. So even just for the example, I'll give you like we can convert it to three-dimensional data. Okay, but just you have to remember that this 12 is always equal to the multiplication of all of this. So guys, we can make the changes to the elements in a similar way. So wherever we have the indexes, right, we can make the changes to the actual elements. So in this case, we can use B to say 0. But you got this example also, right? So here in this case, we just have the elements where A is greater than 4 and we have A LE4 where we have the elements which are less than 4. That is the thing. Then we have this thing. So where we have this multi-dimensional data, okay, there what we can do is, so we have created a B1 and B2. What this B1 is basically 3 values and B2 is there are 4 values. So why this 3 and 4 is the reason is this is trying to point to the axis 0 and this will point to the axis 1. So in our case axis 0 is 3 elements, axis 1 is 4 elements. So it will point to the 3 elements in the axis 0. It will point to the axis 1, 4 elements. Let me print out A. Okay, what will happen when we do B1? Okay, B1 says, so we have second and third value as true. So it is just extracting those rows. And in this case, when we have B2, it will extract those things and then we can have B1 comma B2. Okay, so it will try to take out the intersection. See you guys. So closing the session now. Bye. Thank you.
Acadgild. Average is dead.